Thank you. Hi, I'm Ranny Haiby from the Linux Foundation Edge and Networking. I'm going to speak today about how the Metaverse is affecting networks and how it's affecting edge computing. Just a few disclaimers. I know everybody is giving them, so I feel obliged to do so as well. It's not going to be me telling you how the Metaverse is going to affect edge and networking. It's mostly going to be sharing of my thought and current findings and hopefully starting some conversation. So with that, I think we need to start when speaking about how the Metaverse will affect edge computing, how it will affect networks. We need to be on the same page about what the Metaverse is. Most of us, when we hear the word Metaverse, and myself included, we imagine like kind of legless avatars floating in some 3D space, which is part of the Metaverse. But there are some other parts of the Metaverse as well, or in some other use cases. As you can see here, a partial list of them. Some of them are related to industrial use cases and XR-enabled workforces. And just on the way here, I heard the podcast about how the Microsoft HoloLens is used to train technicians and then to do remote assistance for technicians in the field. So industry is one of the family of use cases. Then, of course, there's enterprise. And again, there's a question if people will switch their virtual workplaces with a Metaverse one, and will they feel comfortable doing so? I have no opinion, but that's another family of use cases that's being discussed. And of course, there is the consumer one with those immersive gaming and avatars and so on and so forth. But as you can see here on the diagram on the right, like the Metaverse is anything that is kind of mirroring or creating a virtual version of the real world. So when I speak, try to keep in mind all these use cases, not just the floating avatars. So what will the Metaverse mean for edge and networking? Metaverse, of course, brings a lot of changes to many different layers of technology. What I'm going to speak about here today is mostly those highlighted things there at the bottom, like think of it as the plumbing for the Metaverse. You heard previous sessions about the higher levels and what it's gonna require for the higher levels, but I'm gonna kind of try to figure out how all of this is going to affect the infrastructure. And the quote you see here is from our dear friend, Mr. Zuckerberg, who spent a buck or two about researching the internet, the Metaverse. So I'll have to take his word for it. And he says that it will probably require more massive changes and more massive advances, not just the natural advance of technology in edge and networking. And to zoom in a little better, what do I mean by the infrastructure and plumbing? So again, this is the big picture of all the relevant technologies, at least many of them based on analysis. But what I'm going to mostly talk about today is like this connectivity thing, the 5G and probably 6G, and edge computing, those two technologies. So when thinking about Metaverse, no matter what the use case is, there's usually a requirement for responsiveness, and that derives requirement on the round-trip latency that is allowed by the network supporting the Metaverse. And that turns to be somewhere around 10 milliseconds, it's at least for some of the use cases. And based on that thing called the speed of light that you might remember from your physics, from high school physics, that translates to about no more than 600 miles. That's in theory. In reality, there are some other bumps in the wire that add a little more delay, so in practice, it's much less than that. So what does it mean? It means that the necessary processing cannot happen centrally at a cloud location, but it means there's a need for more processing at the edge. And the interesting aspect of it is that we have data and computing hungry algorithms related to Metaverse running on resource-constrained edge devices. So again, I don't know what you have in mind when you hear the term edge computing. You may imagine some big data center with thousands of computers that is somehow magically close to the end user. In most cases, it's not. It might be even a single server sitting at the base station of the antenna in your neighborhood, and that server may have less cores than your laptop because it's 10 generations ago with the hardened version. So in some cases, that's what we're talking about when we say edge computing and processing at the edge. So there is a new kind of challenge here where we actually have demand for high capacity from this resource-constrained edge infrastructure. And of course, there are stringent requirements to have no disruption. You don't want it, in the middle of your metaverse interaction, you don't want to feel the real world when it being laggy or disconnected at times. And that creates a whole world of new requirements for the network and the infrastructure. I won't go into it, but some of it are just more of the same, like more bandwidth. But some of it are a bit different, like you can see the need for symmetrical capacity. So usually when we talk about connectivity, or the way we know connectivity, there's much more demand for the download bandwidth, but with Metaverse, it might be one of the use cases where there's a need for symmetrical bandwidth or high bandwidth in the uplink channel as well. So when I try to kind of analyze what the Metaverse would mean for the networks, I kind of found these 5 types of requirements or family of requirements. So we have immersive 3D streaming, we have communication that is not limited to one channel, so it's not just visual or audible, it's also haptic, where you have to interact with devices in the physical and virtual world. There is, of course, this need for real-time interaction, and also throughout all the use cases, there is a need for this physical and virtual synchronization of the world. So it's not just a virtual world, but there's a need for a very good synchronization between the physical and the virtual. And what you can see here in the bottom of the table, I pulled it out of some recent research document paper coming from some academic institutions in Hong Kong. But basically, you can see here just what does it mean in terms of reliability, of latency, of the data rate expected for some of the technologies that are supporting the Metaverse. And you can see that when we're starting to use powers of 10 for the bandwidth, that's kind of intimidating. That's pretty much translates to terabits per second. So that's nothing close to where our networks, especially 5G networks, are giving us today. So it's a new dimension of challenges. So how can the networks and edge computing adapt to that? What should they do? So first, the first quote is from a Tech Republic article about how the Metaverse will be supported by technology, and there's a call here for a kind of an industry-wide effort or a joint effort, which is kind of a precursor to open source software, which I'm going to talk about in a few seconds. But there's definitely a need for an industry-wide effort here to create these technologies that are currently missing. And basically, to support this need for all the requirements I mentioned in previous slides, the only paradigm that comes to mind is some combination of cloud, edge, and end device, for the necessary computation. So some computations needs to be taken care of locally on the edge device itself, because there are some very stringent restrictions on the latency allowed or the responsiveness. But then there may be some other computational parts that might be leveraging the resources of some edge computing infrastructure. Maybe they're more forgiving for jitter and latency, and they can be carried out on the edge infrastructure. But there is probably going to be also some part of the computational tasks that are taken care of by our traditional cloud resources or cloud computing just because of the need for the capacity that cannot be satisfied somewhere else and the ability to maybe compromise on the latency. So bottom line, it's going to be a combination, not just one thing. So how can the network adapt to those new needs, or what can be done to alleviate the load on the networks? So if you take VR streaming, for example, there's probably a need for usage, leveraging of all the available technologies and all the different modes of delivery that networks can offer us. So some things can be done by broadcast, maybe transmitting the background of some virtual world, but then there is needs for some unicast for user-specific content. And also it calls for, because of the aspects I mentioned, call for sharing resources and more of a peer-to-peer economy between devices where they can kind of share data and share the computation and kind of offload the central network and create a mesh network between the end devices. That's another way of creating network capacity. Another thing that's relevant to those type of highly immersive VR streaming is looking at the content itself. And I think Royal kind of alluded to the relevant technology, same way we had adaptive bandwidth for video streaming in the past. There are different kinds of technologies or ways to process the video that can reduce the data. And again, maybe not all the entire scene needs the same level of detail, meaning that you may not need all the same level of bandwidth. And this way you can have scalable bandwidth and use the high bandwidth for maybe what's in front of you and lower bandwidth for what's on the periphery. And another technology that may lend itself relevant here is network slicing. It's something that was introduced in 5G networks, where the networks can be sliced virtually into different pieces, each acting as its own network, so to speak, with guaranteed quality of service. And that way we can direct different type of network traffic to different slices. So there could be, the network can offer, for example, one slice with low latency, maybe low bandwidth, and maybe higher bandwidth with higher latency. And then we can direct the different type of traffic to the different slices of the network, each providing the required transport for that type of traffic. Again, when looking at AR, similar tricks can be used and applied by trade-off, again, between accuracy and latency. This way, we can either alleviate the network from the need for low latency or use different network slices and put only the very latency-sensitive traffic on the network slice with low latency, the ultra-low latency one, and then the rest of the traffic can go on other slices, like the best effort or some trade-off between that. Another promising technology for kind of alleviating the load on the network is semantic communication. And this is something that I pulled straight out of the research papers. So there's I'm not aware of any existing implementation of that. But basically think about, instead of kind of transmitting an entire scene made up of bitmaps or vector graphics, you can kind of detect what's in the scene, and instead of broadcasting the video stream of myself speaking here, you can just transmit the metadata saying a person speaking in front of a room and kind of reduce the bandwidth. So that is a promising technology, but as I said, it's kind of nascent and exists mostly on research papers. I haven't seen a real implementation yet. Again, when speaking about Metaverse, it's not all those flying avatars. So one use case that we're starting to see emerge is this digital twins that, again, Royal kind of alluded to. And that has use cases in multiple industries and use cases. It could be for a factory, It could be for maybe more consumer-oriented things. One of the interesting things, and kind of might be confusing, is mobile networks themselves are very hard to design, build, and operate. There are millions of parameters that needs to be taken care of and adjusted constantly, and there's really no methodic way of doing it properly. It takes a lot of trial and error and constant tweaking. And one of the approaches that is emerging is using digital twins, meaning simulating the entire physical wireless network out there in a city or a rural area in some computer simulation and tweaking the parameters there and then applying them to the real network. So that's one use of digital twins that we're seeing for the network themselves, but there are many others as well. And then when we talk about rendering the necessary images or videos or 3D graphics on the edge, again, we're talking about a combination of a device and edge and cloud. So it's not going to be probably just one place. So there is, as I said, there's a need for optimization for the compute demand, because there are no infinite resources, especially at the edge. So that adds another level of complexity. So if managing your on-premise compute is hard and managing your cloud compute or other different availability zones is hard, then imagine having to manage your compute resources over thousands of edge sites. So that adds a level of complexity that needs to be taken care of when we speak about edge computing. So it's not just running the workload, it's also managing them and orchestrating them all together. So a few things about what's already going on in edge computing scenes, in the edge computing scene, and basically in the open source edge computing scene, which I'm close to. I know this slide is a bit overwhelming, so let's start with the maybe bottom half that kind of shows what open source edge computing projects are doing. And the point there is that open source projects are treating this domain of edge not as a discrete set of locations like far edge, close edge, cloud, or whatever, but rather as a continuum from the very extreme edge of the user device and all the way back to the central cloud. And what open source projects are doing are addressing the needs of those edge computing use cases in kind of several dimensions, and that's kind of the vertical axis. So we have open source projects that are dealing with the infrastructure and how you build and manage edge computing, and also about how you provide a common building blocks for the applications that run on the edge. And you can see Edge Foundry, EdgeX Foundry, and Fledge, which are kind of focusing on industrial IoT edge use cases. But you can see across the board here, there are projects all over the place, and they're addressing different needs of edge computing for different use cases, and Metaverse included. Here you can see some of the use cases or blueprint that one of these projects is dealing with. So Acrano is one of the edge infrastructure open source projects. And the way this project is organized is people come up with what they call blueprints, which are kind of recipes of how to solve edge computing architecture for different use cases. So there are many, as you can see by now, there are many different use cases for different types of industries, industrial, home automation, and many things in between. But what we're seeing, for example, in this Acrano project is that people are starting to look at the metaverse and what will the metaverse mean for edge architecture, and trying to provide those blueprints or recipes of how to provide infrastructure, edge infrastructure for metaverse. So this is one of those blueprints. They call it the integrated edge stack for AR and VR. But basically they looked at what will be the building blocks that will be needed to implement AR and VR processing close to the end user on edge compute. And they kind of collected all the necessary parts and building blocks and all the automation that needs to deploy them, and basically you can, if you follow this blueprint, you can easily create an edge infrastructure through automatic deployment tools that actually deploys all these necessary pieces, and it's ready to process your AR and VR streams. I kind of should have started maybe by asking the question of why does open source make sense for edge and metaverse? So what we're actually seeing is that these building blocks that the open source projects are providing are adopted by different verticals or markets or use cases. So you can see here on the top row, kind of from the left side, more on the industrial and energy side of things, and all the way on the right to home automation and healthcare. And what we're kind of seeing is that the use cases that are maturing first are the ones on the left, and as time goes by, we see more and more of the right side of this chart. And the point is that these building blocks or open source projects that are produced by the Linux Foundation project and other open source projects are common building blocks or common elements that can be used across different industries, used by either the network service providers, the enterprises, or the end users, and the same building blocks, or at least a few of them, can be used to support the needs of different of these verticals, and we can imagine that Metaverse will start becoming a prominent vertical alongside these other verticals and will start to materialize very soon. As I said, the open source projects that under the Linux Foundation don't work in a vacuum. They work on integration, and I think you've seen on the previous slide names of many other projects. Not necessarily all of them are developed under the Linux Foundation. They come from different places, but many of our projects are working on integration and taking software from different sources, whether it's Linux Foundation or not, and providing these blueprints or recipes for solutions. Just a quick word about the Linux Foundation Edge and networking. If you're intrigued and want to know more about what's going on there are many ways to get involved. You don't need to feel that if you're not contributing code, you don't have anything to do there. Quite the opposite. Actually, these communities and projects are very open to the word or the opinion of end users or whoever is consuming the technology and trying to build solutions. So if you're just even a consumer of these projects, or if you're just a player in the domain and not yet using these projects, feel free to have a look. It's very simple. It helps to have this Linux Foundation ID, but it's not mandatory, and you can browse the different websites and wiki collaboration spaces of this project. They also have weekly calls and periodic meetings. We also have events where these projects developers kind of showcase what they're doing, and interested companies come and speak about their use of the project. So the upcoming one is in Seattle in November. That's happening in November 15th and 16th, and registration is open. So if you are curious about open source technology for networking and edge, and hopefully how it will be applicable for the metaverse, you're more than welcome to join us at this event. So that's about all I had in terms of slideware and stuff I prepared, but I'm kind of here to, and I'll be here all week, I'm kind of here to learn about what you think. I do admit that I may have overlooked some things or didn't realize other things or whatever, so I'm very open to having a discussion and using that just as a tee off for the discussion about what you think will be the effect of the metaverse on networking. Just, kind of to get you going, one of the things that I'm not sure about, as someone who's been in the networking industry for a little while at least, is will the metaverse will be yet another over-the-top application that just needs more bandwidth, and the communication service provider, network providers will just be required to provide more bits and more bandwidth? Or is there a real opportunity for them to differentiate and provide real value and become a real player in this? I'm asking that as an open question because I'm not sure what the answer is. I have my gut feeling, but then again, I'm open for hearing from the rest of you. There's going to be a BOF session, a Birds of Feather, on Wednesday around the same time, I think, 3:30, 3:40. So as I said, you can either feel free to talk to me in the hallway, or if you think of something for Wednesday's Birds of Feather session, please join us and we can have an open discussion. And again, I came over here to hear your thoughts, not to lecture. Thank you very much.